An inverted conical container has a height of 6 metres and a maximum radius of 2 metres. There's liquid in the container with a depth of y, and the volume of the liquid is given by V is equal to pi r squared y cubed over 3h squared. Liquid is flowing into the container at a rate of 1,000 litres per hour. Find the rate of change of depth when the depth is 1 metre. Give your answer in metres per hour. Well, let's start by drawing a diagram. The height is 6 metres and the radius is 2 metres, and liquid is flowing in at a rate of 1,000 litres per hour. So we know the volume is given by V is equal to pi r squared y cubed over 3h squared. So if we differentiate this with respect to time, we're going to get dv by dt is equal to pi r squared, and if we differentiate y cubed, we're going to get 3y squared, and the 3 will cancel with this 3 on the denominator, so that will just be over h squared, and then this is multiplied by dy by dt. So rearranging, we can say dy by dt is equal to h squared over pi r squared y squared times dv by dt. So dy by dt is the rate of change of height, which is what we're looking for. We know h, we know r, we know y, and we know dv by dt. So it's time to get a calculator. We want to calculate. So we've got the height, which is 6 metres, so h squared divided by a bracket containing pi times r squared, which is 2 squared, times y squared, which is 1 squared. I'll put it in anyway. And that's going to be multiplied by 1,000 litres per hour is actually 1 cubic metre per hour, and as everything else is in metres, we can just put the 1 in there, and that's going to give us an answer of 2.86 metres per hour. So that is equal to equals 2.86 metres per hour. So let's put that into Babbage. We're going to get V is equal to pi r squared y cubed divided by 3h squared. And are we right so far? Yep. So dv by dt is equal to pi r squared y squared divided by h squared times dy by dt. And is that correct? Yes, it is. So rearranging, we're going to get dy by dt is equal to h squared divided by a bracket containing pi r squared y squared times dv by dt. And are we right? Yes, we are. So now we just need to say that that is equal to 2.86 metres per hour. And are we right? Yes, we are. 2b. Calculate how long it will take to fill the container, giving your answer in hours. So what we've got to find out is the volume of this section of the cone. So we can find that by calculating the volume of the cone and then subtracting the volume of liquid. So the volume we're looking for is going to equal pi r squared h over 3 minus pi r squared y cubed over 3h squared. So we can take pi r squared over 3 outside of h minus y cubed over h squared. And we're going to divide this by dv by dt. So we'll get the time is equal to pi r squared over 3 brackets h minus y cubed over h squared, all divided by dv by dt. So let's get our calculator back. So we've got brackets pi times r squared, which is 2 squared, divided by 3, close brackets, times a bracket containing h, which is 6, minus y cubed. Y is 1, but well, I'll put it in anyway, so that's y cubed divided by h squared, which is 6 squared, close brackets, and then that is divided by 1,000 litres per hour, and 1,000 litres is 1 cubic metre, so that's going to be divided by 1, and that's going to give us 25.02 hours. So that equals 25.02 hours. Right, let's put that into Babbage. So the equation of volume, V, is going to equal pi r squared divided by 3 outside of h minus y cubed divided by h squared. And are we right? Yes, we are. So now we can say that t, the time, is equal to 25.02, and if I don't put the hours in, I'll get no units, so we'll change that and we'll put the hours in. And are we right? Yes, we are. And that's how you answer question 2.